Thanks, you guys, for joining us to this session, Behind the Curtains, the story of a Backstage RCE. And we wanted also to thank our host today for hosting us in this beautiful venue, this amazing conference. So my name is Abeles. I'm the head of security research at Ostrovsky Security. We are an application security startup where in our free time we research open source projects like Backstage that you're going to see today. And here are the results of this research.
I'm Yuval. I'm a former employee at Ostrovsky, where I had the pleasure of working on this project with both Gal and Daniel, and currently I'm working on a new startup.
I am Goldshtein, security researcher for Ostrovsky Security.
Cool. So what do we have today? We're going to give you a brief introduction to what is Backstage, what is it used for, why people use it anyways. We're going to jump into the threat landscape of Backstage and why it makes such a lucrative target for threat actors. Then Gal will show us a beautiful demo of a threat actor from the internet trying to exploit this vulnerability and successfully running code execution on the Backstage instance. Then we're going to show you some information we gathered in our research on Backstage instances in the wild and some wild things we found in the way. And we're going to wrap up with a couple of key takeaways that we found during this research, both for security researchers and both for developers. So stay tuned.
OK, so before we deep dive into the vulnerability, let's first talk about developer portals. So imagine developers. These days, they don't just write code. They are also making trips to their cloud provider console, troubleshooting Kubernetes, managing security and compliance, not to mention hunting down for documentation. Each task has its own tools and UI to learn, and it doesn't take long for context switching and cognitive load to take their toll. And it's happening all across the board. The more developers grow, the more chaotic and fragmented their ecosystem becomes. A developer portal unifies all tooling, data, documentation, and services behind a single pane of glass, reducing those pains and problems. Well, with over 20,000 stars on GitHub, Backstage is one of the most common dev portals out there. Developed by Spotify, Backstage is an open-source platform for building developer portals. It streamlines the development process from end to end. And as part of this streamlining process, Backstage connects to the most critical infrastructure. This includes production environments, databases, internal services, and more. This makes Backstage an extremely lucrative target for threat actors, as taking over a Backstage instance can allow for lateral movement across an organization. Backstage is composed of three main components. First part is the core, which holds the base functionality of Backstage. Second part are the apps, which are running instances of Backstage that can be tweaked and modified. Third part are the plugins. Plugins hold additional functionality on top of the base functionality of Backstage. They can be developed internally by a company, or they can be open-sourced and reusable. Backstage comes pre-installed with some built-in plugins, and one of those plugins is called scaffolder. As there are repeated views and tasks inside of Backstage, scaffolder allows to create new projects, edit existing ones, or simply perform repeated tasks in a consistent manner. It does so by receiving its input via a YAML file defined by a user. It then renders this YAML file using the Nunjax rendering engine, which is a common rendering engine written in JavaScript. Nunjax is known to be vulnerable, even so that back in 2021, a vulnerability was released in Backstage, exploiting the Nunjax engine and the scaffolder plugin specifically. Exploiting Nunjax is pretty straightforward, just placing double curly brackets and calling the range.constructor function. Any code that resides within the constructor function gets evaluated and executed, leading to remote code execution. In order to mitigate this vulnerability, Backstage had implemented the secure templater class. Secure templater class is responsible for securely rendering template files provided into the scaffolder plugin. It does so by utilizing the VM2 sandbox library, which is a common sandbox library also written in JavaScript. So now, instead of calling the rendering engine directly, scaffolder calls the secure templater, which in turn spins up a VM2 sandbox instance. Within this VM2 sandbox instance now resides the entire Nunjax rendering engine. This means that if a malicious user tries to exploit the previous vulnerability we mentioned, his code would eventually end up executing inside the sandbox, instead of taking over the machine hosting the Backstage instance. So at this stage, we started poking around with the question of how secure the secure templater really is.
So let's talk a bit about what is VM2. VM2 is a popular sandbox library implemented in JavaScript with over 4 million weekly downloads. It allows the developer to run untrusted code in a secure environment where the code is running inside the sandbox will not be able to affect the surroundings. The library name stems from the built-in VM module of Node.js, which also allows running the code in a separate context, but does not provide the same security that VM2 attempts to provide. So VM2 under the hood utilizes 3 main techniques in order to prevent sandbox escapes. The first one is JavaScript proxies. Proxies allows the VM2 developers to intercept the arguments passed to the different functions called from inside the sandbox, and also to intercept the return value. That allows the VM2 sandbox to prevent dangerous objects from being accessible from within the sandbox. The second technique is object freezing. This technique allows VM2 to prevent modifications of the built-in objects accessible inside the sandbox. And the third one is prototype manipulation. Not all the prototype objects accessible within the sandbox are the same ones that you will receive while working outside of it. So after getting familiarized with VM2, we asked ourselves how the previous vulnerabilities in VM2 looked like and what techniques they did manage to exploit. By running a simple search on GitHub issues, we could see that there were more than 10 different sandbox escapes reported to the VM2 maintainers in the last couple of years. This was a strong signal for us that there might be more waiting to be found. While looking deeper into the different techniques used in the previous exploit, we saw a concept that was shared between some of the previous exploits previously reported. And it was abusing the error mechanism of Node.js in order to escape the sandbox. In the picture, you can see a code taken from the built-in error mechanism of Node.js, where the code attempts to check if the prepare stack trace function is defined under the global error object. And if it is defined, it attempts to call it by supplying 2 arguments, an error representation as a string of the error record, and the second one is an array of call site objects with which each call site object contains different functions that allows to understand what exactly happened and in which frame during the program execution. The method of the call site object that allowed escaping the sandbox was the getThis method. The getThis simply returns that this object was accessible during the execution of the specific stack frame. So while looking into the VM2 code base, we could see that they attempted to mitigate such escape attempts. And they did so by defining a getter and setter around the prepare stack trace function. And each time the code running inside the sandbox will attempt to set this property, this prepare stack trace function, it will first pass through the VM2 sandbox, which strips out the dangerous objects containing inside the call site objects array, and only then the method defined inside the sandbox will be called. While seeing these mitigation attempts, we asked ourselves, what would happen if we would simply try to create a new error object, override the existing one, and under this new object, we will define the prepare stack trace function. This simple trick allowed us to escape the sandbox once again while abusing the same error mechanism. This vulnerability was quickly patched by the VM2 maintainers, and it was assigned with CVE 2022-36067. And as you can see, it got the CVSS score of 10, the maximum score possible.
Okay, great. So now we have 3 important pieces of information. We know the YAML template format that scaffolder receives as input. We have the nunjax rendering escape, but mind you, using this rendering escape, the code executed inside of it would still reside inside the VM2 sandbox. But combining those 2 things together, along with the VM2 sandbox escape, and we should be able to gain remote code execution on the Backstage instance itself. So combining those 3 things together, and we end up with a YAML looking like this, where if we zoom into the last line, we are able to see our payload. We can see the double curly brackets we mentioned earlier, and a call to the range.constructor function, which allows for code execution. Inside of it, we can see our payload, which is basically the VM2 sandbox escape. This, hopefully, should allow us to gain remote code execution. But sadly, it didn't work. And the reason it didn't work is because our entire call stack had returned undefined as return value for the getThis method. And the reason it returned it is because of something called JavaScript strict mode. So before we go any further, let's quickly go over what JavaScript strict mode is all about. So JavaScript strict mode is a restricted variant of JavaScript. It allows for a more readable and resilient code. Any function can opt into strict mode. Once a function opts into strict mode, it makes all of its members and data inaccessible from outside of it. Another important thing about strict mode is once a function opts into strict mode, it makes the entire call stack up into that function also inaccessible, opting into a semi-strict mode. So this explains why we got undefined returned as value, because a specific function in our call stack had opted into strict mode, making the getThis function return an undefined. So going over the call stack, and we were able to find this specific function. This function was the renderString2 function. It's a function that resides within the nunjax rendering engine. Mind you, this function still resides within the VM2 sandbox instance. So at this point, we had thought to ourselves, how can we escape the strict mode variant? So what we thought of was, what if we declare a new function inside our payload that performs the VM2 sandbox escape? We would then override the renderString implementation with our own function that performs the VM2 sandbox escape. Only this would happen before the renderString implementation opts into strict mode, allowing us to gain code execution from a non-strict context. Only thing left to do now would be to call this function from a non-strict context. So lucky enough, we found the right place to do so. We found inside the scaffolder plugin a code snippet that allows to call the same secure templater instance twice. In the first call, our template is rendered regularly, but in the case it raises an exception, a second call to the same secure templater instance would be performed again. Only this time, the renderString implementation would contain our own sandbox escape, allowing for our code execution to happen. So we end up with a payload looking like this, where in the third line, we are able to see we are overriding the renderString implementation with our own implementation that performs the VM2 sandbox escape. We are then in line number 16, performing a trigger raise function, calling the trigger raise function, which basically does not exist. This would trigger a second call to the secure template render function. Only now, the render string function would contain our sandbox escape, calling it from a non-strict context, allowing for the VM2 sandbox escape. So that's enough talking for now. Let's quickly see a demo.
So as you can see, we have a vulnerable instance of Backstage right here, and the exploit, the HTTP request exploiting the vulnerability. We will send it through Backstage, and we should hit our breakpoint along the way. So here we are in the scaffolder plugin, right before the first call to the Nunjax rendering engine. So this is the first stage of our exploit. In this stage, we'll only override the render string function with our own implementation. So as you can see now, this is the code that represents our template within the Nunjax template engine. The next step would be to raise an exception. As you can see, an exception was raised, and the scaffolder plugin took care of this exception, and it will try to call the render engine once again. This time, the render string function will contain our own payload. So as you can see here, we landed once again in our overridden render string function. And this is basically the code that exploited the VM2 sandbox escape. So if we will place a breakpoint right here and let the code keep running, we hit this breakpoint. And as you can see, we have an array with our call site objects. If we will access the call site object in the index number 2, we should get a non-sandboxed instance allowing us to execute code. So as you can see here, this is the global object of the program, unsandboxed one. But if we will access index number 1, you can see that this one is a sandboxed one, and we can see the VM2 global object here. So all we have to do now is just let this line of code run, which will execute our command. Thank you.
Cool. Let's jump back. Awesome. Thanks, Gal, for this amazing demo. Showing a calc is always a blessed thing. After we saw the vulnerability itself, and I think you were convinced that it's quite a serious one, we wanted to really assess the public stance of how many instances of Backstage do we see in the wild, and what could a threat actor do when he sees one. So to do that, we used the internet search engine called Shodan, and for those who are not familiar with Shodan, they basically scrape every single IP address on the internet on several ports, and they have all those plugins that can parse the data. And one of those plugins is the HTTP favicon hash plugin. Now, every web application has what is called a favicon file, which is basically this little icon that you see in the browser that says, hey, this is the image of this application. Now, standard applications that have a fixed favicon file can be used to uniquely identify those instances by hashing the favicon file. So essentially what we did is hash the favicon, provide it to Shodan, and Shodan is now searching all of those instances that match this criteria. So it basically gives us the option to uniquely identify all the Backstage instances that Shodan is aware of. We found about 600 instances of Backstage in the wild, and you can see here the geographical distribution of those instances. But we should keep in mind that Shodan is basically give us all the information they have. Now, there are hundreds and maybe thousands of private instances of Backstage in private organizations. And moreover, there is a thing that a company or someone that owns this instance can opt out from the Shodan search results. So they can say, hey, don't show me in Shodan, and we would not see them in those results. So do keep in mind that this number stands for all the public instances that Shodan is aware of. So there might be more. Here you can see the distribution over time of Backstage instances, which really makes sense because in mid-2020, Backstage was first created. So we can see that from mid-2020, we see an influx of Backstage instances up until 2023, where we saw that there are about 600 instances. Now, finding an instance in the wild is worthless if you don't have nothing to do with it. So we dug into the documentation of Backstage to find all those small quirks, so you don't have to. And the first one we found out is that Backstage supports what they call guest access, which is pretty straightforward. They give you the option to log in to a Backstage application without any authentication details. So a user from the organization might be using the Google authentication or Azure AD for that matter. And here we can see that you can access as a guest. Now, if you access as a guest, like in a normal situation, you wouldn't be able to see much because you don't have any integration with Github or Google. You can't see anything that requires authentication, but you do have access to the scaffolder plugin. So once you have the access to that scaffolder plugin, you can actually execute the payload that we showed you earlier. So basically, it becomes from an authenticated payload to an unauthenticated payload. Another thing that we found really bizarre, if you can call it that way, is that the documentation of Backstage clearly states that the authentication mechanism that you provide from the front end, like we've seen before with GitHub and Google and so on, is only applied for the front end. Let me say that again, it only applies to the front end. Now, if you might hear this and be shocked, it's correct because that is not fine. Because any user on a misconfigured Backstage instance can essentially directly access the backend of the application. So if the user tries to access the front end, he sees this page that says, hey, you need credentials, but if they make direct contact to the backend, he can actually trigger the API endpoint that is responsible for the vulnerability we just found. So we can execute this vulnerability without any authentication details whatsoever. Now, keep in mind, this is a misconfiguration, and there are certain instances that have configured Backstage properly, so this won't work, but it's a documentation quirk that we have to show you guys. So in terms of the disclosure timeline, this whole process took about 2 weeks. Back in August 18th, we reported this issue to Spotify via the HackerOne platform. They were really swift in seeing this issue and triaging the report. And by August 29th, Spotify has released a security release, a critical security release that patches the vulnerability we just showed. And because they only version bumped the dependency of VM2 that we showed you that was vulnerable, they gave it a CVSS score of 9.8, but the CVE that we showed you earlier is a CVSS score of 10. So keep that in mind. Cool. So we got to the stage where we wanted to talk about some key takeaways that we found during this research. And we divide them into what we can take for researchers, what developers can take from it, and what everyone can take from this presentation. The first one relates to the fact that when we saw VM2 and we saw the 10 vulnerabilities or even more that existed in the ecosystem for the last 2 years, we could have been easily intimidated and drop the research, because if someone found an RCE 10 times in the last 2 years, it sure means that the product is properly patched by now, and we shouldn't find anything new, right? So this conception or misconception really hit us when we found this vulnerability again after 2 years of about 10 instances of vulnerabilities that were found. And the gist of it is that where there is smoke, there's fire. So don't get intimidated by a project that is heavily researched or has a lot of vulnerabilities exposed or publicly exposed. If this is your interest, go for it. The second key takeaway really ties down to the previous presentation that we've just seen about supply chain and how supply chain affects your organizational security posture. When you're integrating such an application, like Backstage, for example, we're inheriting all the security postures of that application into our organization. What this means is that if Backstage is having all of those integrations with all those, with GitHub and with your Google account and so on, a potential threat actor that compromises that machine can laterally move into your organization and use those secrets against you. So you have to keep in mind that if you're integrating such a solution, your security posture is tightly coupled with that project security posture. The last bullet is, we are all either developers, security researchers. We've been in this industry for a long time. And we know that documentation can be a bit tedious to read. So we read the minimal amount of documentation to make the project work. But essentially, there are a lot of documentation quirks that are hidden in the documentation. And you can avoid such a situation where you don't expose your authentication method to the backend by just reading the manual. Thank you guys for listening to us.
Thank you.
And of course, if you have any questions, you can feel free to contact us after this session or on social media. We would be more than happy to answer your questions. Thank you.